All right, now we're in section 1.6, and notice that we skipped section 1.5. We'll get to that in the next PowerPoint lecture. This section 1.6 isn't really dependent on section 1.5, so it's okay if we go out a little out of order. All right, so we're going to be dealing with direct variation in this problem. So if we are told that we have a problem that's varying directly, it's also known as a direct variation, but the key word in the problem is varies directly. We can see that it varies directly in this problem. And it mentions that some variable, in this case y, varies directly as the variable x. Then we're in this form right here, y equals x. So it's something varies directly with something else. And in this case, we have the distance of sound travels. We can call this letter D, distance, varies directly as the time it travels. So we're going to use the letter T for the part that comes after varies directly, similar to the x. So y varies directly with x. Another way of saying this is directly proportional. That may be another wording you may see. Typically you'll see varies directly, but they're equivalent to each other. So in this problem we see varies directly, and so the y is kind of like the d, and the x is kind of like the t. So something varies directly with something, and so we know that this fits into the form. What this tells us is d equals k t. Now they have this other letter k. Now they define k here. K, it's known as the constant of proportionality, or the variation constant. And there may be other words that they use out there in other textbooks and out there in the internet that you may read into if you look into outside resources. But we're going to be calling it the constant of proportionality, or the variation constant. It's kind of a universal variable. They always use the letter K for this, but so what we need to do is solve for K. So if sound travels 1,340 meters in 4 seconds, find the distance sound will travel in 5 seconds. Okay, so this gives us the information that we need. So we're going into kind of the next phase of the problem. I'll use a different color. So we know that if sound travels 1,340 meters in 4 seconds, that's essentially giving us the distance. This is the distance, d, and this right here is the time, t. So they give us a distance and a time that we can plug into this equation, and that will allow us to solve for the constant of proportionality. So we can substitute 1,340 in for d and 4 in for t, and we can solve for k. So k is equal to 1,340 divided by 4. So I'll plug that into my calculator right now. 1,340 divided by 4, and I get 335. So we have just determined that the constant of proportionality is 335. So we actually have a more specific direct variation equation. Rather than y equals kx, that form, or in this case d equals kt, we have d equals 335t. So we have the constant of proportionality, that we can plug in for k, and this is the equation that connects distance of sound travels with the time it travels. We can use this equation now. So if we wanted to, now this is the last phase of the problem, if we want to determine the sound, find the distance sound will travel in 5 seconds, we can do that. So we want to know what d is. We want to know the distance sound travels. So we want to solve for d in 5 seconds. So 5 seconds is t. We can plug in 5 now and solve for d. So 335 divided by, or not divided by, but multiplied by 5. We get 1,675. And remember your units. In this case, we have meters. So we know that the distance the sound traveled in 5 seconds, based off the speed of sound, is 1,675 meters. All right, let me know if you have any concerns. Just keep in mind that you may be asked for K. They may just ask for the constant of proportionality in a problem. They may ask, or they may have you do this whole 3-step process to solve for some unknown value at the end. They may ask you to solve for the equation, and that's it, like d equals 335t. So keep that in mind. You may be asked a certain part of this problem, and you have to know when to stop. But this gives you the whole process, and yeah, let me know if you have any concerns.